And there's 4. Excellent. Let us begin. Good morning, everybody. Welcome back to Algebra 2. Well, as with everything, right, it's not always about why. Sometimes it's about why not, because we can, right? Why wouldn't you want to study and practice more math? It's awesome stuff. Okay. So anyways, we have been running through our final section of the semester, rational exponents. We finally got to the real deal, the actual fraction as an exponent thing, right? We got that definition yesterday, and we had some practice with that. So let's go ahead and run through the answers to those practices, and then for the rest of the day, it's just more practice, actually. I wish I could jazz it up even more. If you were here, maybe we'd try some kind of a game or competitive thing. If you want to race, go for it. But here are the answers from yesterday's. And that one's in blue because I did it in class. I think I can bump up the pen size there a little bit. No, I'm going to just... There we go. More in line with the rest of them. All right, any questions there on the first page? Nobody has trouble interpreting my handwriting? Okay. And on to the second page when we start throwing some variables into it, not just numerals. A little bit bigger, there you go. And that last section, as mentioned, since it's already in radical form, please leave it in radical form, even though I would say many of these are better conceptualized, perhaps, as in fraction radicals, such as like, okay, this is 6th root, but I know I can take the square root of 16. Well, if you just represent that as exponents, now all of a sudden you're just combining exponents. Oh, well, okay, to 1/6 power, but this is 4 squared, so it's 2/6, and right, things simplify there. Okay.
Can you go over 18?
18? Sure, let's do 18. All right, I really expected 16, but 18, okay. Here we go. Let's see. We've got radical in the denominator, and there's nothing really to do up top here, right? It's 4th power and 3rd root. That's 4/3. I'm just going to convert that 4 on top. Let me get a smaller pen there. B to the 4/3 times A. And this is all of that AB cubed to the 1/2. And what they want you to do here is the good old rationalize the denominator. It's kind of fallen out of fashion recently, but it's good skill to have. So let's try it. What we're going to do is we're going to get rid of that in the denominator by multiplying by a foo here, our fancy form of 1, which in this case is exactly the same as the denominator, above and below, right? So what this does then, I have something to the 1/2 power times the same thing to the 1/2 power, and now 1/2 plus 1/2 is 1 whole. And now at least over here on the denominator, I have just a and b cubed. And now up top, I have a times a to the half. So that's a to the 1, right, an invisible 1, plus a to the half. So now I have a to the 3 halves. And how many b's? I have b to the 4 thirds plus b to the 3 halves. Follow me there? 3 times a half. So 3 halves plus 4 thirds. Oh gosh. 4 thirds plus 3 halves. Do not reduce the 3's. We're adding fractions here, not multiplying. Okay, I know it's tempting. It looks really good, doesn't it? No. Okay, adding. So we've got to change all these to sixtises. So double that makes 8. Triple that to get 6, right? So times 3, so 9. So 8 plus 9, 17 sixths. Ooh. Okay, b to the 17 sixths there. So that's that dealt with. Okay, now we just need to finally reduce. We can see I've got a to the 3 halves there, a to the 1, and now I'm dividing everything. Now I just subtract my fractions, and I get down to how many a's? Well, 3 halves minus 1 leaves us with 1 half. How many b's? And this is where I don't like the way they represent this here from the book. They did the same thing with, what was it, 9. Yeah, it was really funny. I think they were trying to avoid the negative as well. So we'll see here, I'm going to end up with a slightly negative result. That's okay, and then you'll see how it converts to that final form. I would probably not have left it with that. Like, I've definitely got a different power of b there, but we need it as radicals, right? So 17 sixths is 6, 12 plus, well, 13, 14, 15, 16, 17, 5, right? So this is 2 and 5 sixths. And we have b to the 3 down there, right? So think about that. I can eliminate one of these, or 2 levels of b, with that. See how that reduces there? I can subtract those out, subtract 2 from both of them. And then that gets me the answer they have here, just re-represented in radical form. A to the 1 half is square root of a. B to the 5 sixths is b to the 5th sixth root. And then I have 1 power of b left in the denominator. So it's a fully rationalized denominator. Okay? Because if this was exponents, we could definitely take this to be a to the 1 half times b to the, well, 5 sixths minus 1 would be negative 1 sixth, right? Well, you got to have it as radical form. Well, there's not a negative root. Okay, this is, let me write this here. B to the negative 1 sixth is not equal to negative 6th root of b. Okay, it's just not. The negative exponent means it goes in the denominator. But the whole point is we were trying to get the radical out of the denominator. So in order to have no radicals in the denominator and thus no negative exponents shown, we got to leave b listed there twice. That's why they do that. I think this looks just way better and easier to work with. Again, that's why I'm biased towards the exponents there. Otherwise, you'd put b down below and be a to the 1 half divided by b to the 1 sixth. But they want only whole numbers, integer exponents in the denominator. Okay, there you go. That's why they wrote it that way. So if you have anything along here, or right, you could have square root of a divided by 6th root of b. that would at least be simpler than what we started with. So I'd take that. That looks pretty good to me. Okay, any other questions? No? All right, then there you have it, folks. That was the first sheet. Now for today, it is just more straight up skills practice. Drill it, practice until you can't get it wrong, right? I've got, I don't have it on my wall yet, but that's one of my new quotes for this year, right? Is do it until you can't do it wrong. Okay? So that's what we're going to do here. More writing in one for the other, more evaluating, more simplifying. But at least it's only one side and 26 questions this time. Okay? So if there are no additional questions, then I will leave you to it. Of course, if you do run into trouble, I will be here. Feel free to ask.